I've locked them in the furnace room and taken their shoes. They'll never get out.
Oh no! Anti-physics man locked us in the furnace room. How will we get out? Let's look around to see if there's anything that can help us get out. Oh look, there's more! Look at all these shoes! Anti-physics man stole our shoes, so we can find new ones here to wear when we escape. But which ones will we choose?
We need to find out which shoes have the largest coefficient of static friction on different surfaces, because this will tell us which ones we should choose in order to get the best grip. But how can we figure out which ones have the largest coefficient of friction? Let's consider a stationary object on an inclined plane. We know that there are several forces acting on this object: the normal force, the force of gravity, and the force of static friction. If there was no force of friction, the object would immediately slide down the plane, no matter what angle it was placed at. However, there is usually a force of static friction between the object and the surface, which keeps the object at rest. As the angle of incline increases, the force of static friction increases in order to counteract the force of gravity. It will increase until it reaches its maximum. Then the object will begin to slide. If we consider the angle of the inclined plane to be the angle at which static friction has reached its maximum and the object is about to start sliding, we can perform some useful calculations. First, let's consider the forces acting in the x direction. The force of static friction opposes the x component of the force of gravity. We can label this equation with the number 1. Next, let's consider the forces acting in the y direction. The y component of gravity opposes the normal force. We can label this equation with the number 2. Now we can substitute equation 2 into equation 1, and we find that the coefficient of static friction is equal to the tangent of the angle at which the object starts to slip. Therefore, we know that when the angle is greater, the coefficient of static friction is greater, and the object will have a greater capacity to resist motion on that particular surface.
So, how can we test this? Well, Anti-Physics Man's lair has 2 types of flooring, wood and tile. If Anti-Physics Man sees us, they'll turn on the sprinklers. We want to see which pair of shoes will give us the most grip before the sprinklers turn on, and which will give us the most grip after. Lucky for us, the furnace room we're locked in has spare floor materials, some water, and a protractor. How convenient! So, we'll test each shoe by slowly tilting the plank or tile and seeing how much it needs to be tilted before the shoe starts slipping. We'll record the angle that the board makes with the horizontal and see which shoe needs the largest angle to start slipping. We'll test for the sprinklers by wetting each surface and testing each shoe again. Hey look! Graphs of our results. Looks like the running shoes are the best choice for both surfaces dry, and the slippers are the best choice for once the sprinklers turn on. Quick, let's grab them and sneak out.